Okay. Question one, intuitively, we want to remove the denominator. However, because we don't know the sign in front of x minus 5, so we cannot just multiply both sides using x minus 5, because we don't know if we need to change the direction of the inequality symbol. So instead, we put everything on one side of the inequality. For example, we put everything to the left-hand side. Okay, original inequality is equivalent to this one. And then it is equivalent to, let's rewrite the expression here using the common denominator, which is x minus 5. Okay, and simplify the numerator. Okay, minus 3x minus 6x gives us minus 9x. And plus 4 minus 5. Sorry, this is not minus 5. It should be plus 30, right? Minus 6 times minus 5 is plus 30. So minus 9x plus 30 plus 4 is plus 34. Divided by x minus 5 greater than 0. So we come to an end that the ratio of these two numbers is positive. So this means either we have two positive numbers or we have two negative numbers, right? Okay, so this is equivalent to first case, the numerator is positive and the denominator is also positive. So positive number divided by a positive number can give us a positive ratio, right? Or the numerator is negative. And at the same time, the denominator is also negative. In this case, negative number divided by a negative number also gives us a positive number, right? This is, these are the only two cases. And then we need to solve them separately. For the first case, we can get x is smaller than 34 over 9. And x must also be greater than 5. Or second case, first x should be greater than 34 over 9. And x is also smaller than 5, right? And next step, we need to compare the two numbers here to decide which number is greater. So 34 over 9 is about 3 point something, right? So of course, 5 is here. If 5 is here, 34 over 9 is here, right? And the solutions must be, for the first case, x is smaller than 34 over 9 and greater than 5. There is no overlapped area, right? So the solution for the first case is x belongs to an empty set. Okay, the solution for the second case, it says x must be greater than 34 over 9 and smaller than 5. So this is the overlapped area, right? So the solution for the second case is x must be greater than 34 over 9 and less than 5, right? Okay, so by considering these two cases, the final solution must be x greater than 34 over 9 and smaller than 5. Okay, any questions? have a look at this. Do you have any questions? No? Okay, let's see the next one. Okay, Q2. Again, first step, you need to put everything on one side of the inequality. Okay, minus x becomes plus x, and plus 5 becomes minus 5, and this is less than 0, right? And next step, we need to rewrite the expression using the common denominator, which is x minus 5. So 20x over x minus 5 plus x minus 5 times x minus 5 over x minus 5. This should be smaller than 0, right? And this is equivalent to 20x plus x minus 5 squared over common denominator x minus 5 less than 0. This is equivalent to 20x, and then we can expand this expression using the formula, right? This is x squared minus 10x plus 25 over x minus 5, and this should be smaller than 0. And this is equivalent to x squared. 20x minus 10x is 10x, right? And then plus 25 over x minus 5, and this should be less than 0. And this is equivalent to, according to this formula, the numerator is actually x plus 5 to the square, right? I hope you can see this. X minus 5, and this is less than 0, okay? And if you have a ratio that is less than 0, what does this mean? This means this is equivalent to the signs in front of the two numbers, in front of the denominator and the numerator should be different, right? So whether we could either have negative numerator and at the same time a positive denominator, right? Or at the same or for the second case, we can have a positive numerator and at the same time negative denominator, right? Do you understand? Laura, do you understand? These signs, these directions are not randomly assigned, but is determined by the direction of the inequality symbol here. Do you understand? Okay. All right. And next step, we need to solve the two cases separately. So for the first case, something squared is less than 0. This cannot happen, right? No matter what x is, this cannot happen because something squared must be greater than or equal to 0. So the solution for the first case is x belong to an empty set. Or for the second case, note that something squared must be greater than or equal to 0, right? As long as we do not let x be minus 5, this is always greater than 0, right? Because when x is minus 5, x plus 5 squared is 0. If x is not minus 5, the expression here must be greater than 0. Okay. Second, x must be less than 5, right? Okay, so considering both of the situations, final result must be either this one or this one, right? So final solution is x must be less than 5, and at the same time, x cannot be minus 5. Okay, have a look at this. Do you have any questions? No? Okay, let's see question 3. And this time we have ratio that is smaller than or equal to 3, right? First of all, again, we put everything on one side and rewrite the expression using the common denominator, which is 4x plus 6, right? And this is smaller than or equal to 3. And this is equivalent to expand the numerator here, minus 12x, and minus 3 times 6 is minus 18, right? Over the common denominator, which is 4x plus 6. Sorry, this is 0, not 3. Okay, this is equivalent to minus 7x minus 12x is minus 19x. Minus 3 minus 18 is minus 21 over 4x plus 6. Smaller than or equal to 0, right? And then we can time a 2 to both sides, right? Multiply a 2 to both sides because we can easily cancel a 2 with 4x plus 6, right? Okay, and also because 2 is positive, so we don't change the direction of the inequality symbol. So the left-hand side becomes minus 19x minus 21 over 2x plus 3. Smaller than or equal to 0, right? Okay. Then this is equivalent to, we have a ratio that is equal to or smaller than 0, right? So first of all, first case is this ratio can be exactly 0, right? Or let's say the ratio here can also be smaller than 0. And we have already know how to solve the second case, right? Okay, so this is equivalent to, first case is actually an equation. If we have a ratio that is 0, first of all, you need to ensure that the numerator is 0. And at the same time, the denominator is not 0. Or the second case, we have already know how to solve this. If you have a ratio that is smaller than 0, what is it equivalent to? Okay, Dora, can you tell me what is the equivalent expression? Yes, the signs in front of the numerator and denominator must be different, right? So if we have a negative numerator, then the denominator must be positive, right? Or how about the other case? How about the other case? Yes, if we have a numerator that is positive, the denominator must be negative, right? Okay, so now the original problem is decomposed to these three systems. We need to solve them one by one, which is not very difficult, right? First case, first of all, x should be equal to minus 21 over 19, right? And at the same time, x cannot be minus 3 over 2. Second case, first, x should be greater than minus 21 over 19. Second, x must be greater than minus 3 over 2, right? Okay, third case. First, x must be smaller than minus 21 over 19. Second, x must be smaller than minus 3 over 2, right? Okay, next we need to compare these two numbers, which is larger. So minus 21 over 19 is about minus 1.1 something, right? And minus 3 over 2 is exactly minus 1.5. So which one is larger? Of course, minus 21 over 19 is larger, right? So if minus 21 over 19 is here, minus 3 over 2 must be on the left. Okay, so now let's write the final expression, final solution. First, x can be exactly minus 21 over 19, right? Or second case, x should be greater than both of the two numbers. This can be combined to x is larger than the larger number, right? Which is minus 21 over 19. Because if you can see here in the diagram, if x is larger than minus 3 over 2, and x is larger than minus 21 over 19, this is the overlapped area, which is x must be greater than minus 21 over 19, right? Okay, so third case, x should be smaller than both of the two numbers, right? First of all, x should be smaller than this number. Second, x should also be smaller than this number. So what is the overlapped area? Overlapped area is, of course, here, right? Which is x should be smaller than the smaller number, which is minus 3 over 2. So this can be combined to x smaller than minus 3 over 2. Okay, so considering all of the situations here, final solution must be first, x can be greater than or equal to minus 21 over 19, right? Or x can also be smaller than minus, let's write it here. Okay, x can also be smaller than minus 3 over 2. And this should be our final solution. Okay, please have a look at this. Do you have any questions? Oh, okay, let's see question 4. All right, original expression is equivalent to, let's put everything on the left-hand side, which is minus 24x over x plus 6 plus x plus 6, right? And rewrite the expression using the common denominator, which is x plus 6. And this should be greater than or equal to 0. And next step, let's expand the numerator and simplify it. Minus 24x. Okay, according to the formula, x plus 6 squared is x squared plus 12x plus 36. And over the common denominator, which is x plus 6, greater than or equal to 0, right? And this is equivalent to x squared plus, minus 12x plus 36 over x plus 6, greater than or equal to 0, right? And according to the formula, the numerator is actually x minus 6 squared, right? Over x plus 6 should be greater than or equal to 0. Okay, so this is equivalent to, first of all, the ratio can be exactly 0, right? Or the ratio here can also be greater than 0. Okay, and now we need to solve these two cases separately. First of all, if a ratio that is 0, we need to ensure that the numerator must be 0, and at the same time, the denominator cannot be 0, right? This is a solution of this equation. Or second, if we have a ratio that is above 0, that means the signs in front of the numerator and denominator must be the same, right? So we can either have a positive numerator and at the same time a positive denominator, or we can have a negative numerator and at the same time the denominator must also be negative, right? Okay. Next, for this equation, x minus 6 squared is 0. This means x must be 6, right? Okay, second, x cannot be minus 6. Or, okay, second case, x minus 6 squared must be greater than 0. Note that something squared, no matter what x is always greater than or equal to 0, right? As long as we ensure that x minus 6 squared is not 0, it must be greater than 0, right? So this is equivalent to x cannot be 6, because when x is 6, x minus 6 is 0. 0 squared is 0, right? So this inequality does not satisfy. So as long as x is not 6, then x minus 6 squared is always greater than 0, right? Okay, second, x must also be greater than minus 6. Okay, this is solution for the second case. Third case, x minus 6 squared less than 0. This cannot happen, right? Because no matter what x is, x minus 6 squared is always a non-negative number. So there is no solution for the third case. So x belongs to an empty set. Okay, considering all of the solutions, the final solution must be x is either 6 or x is not 6 and x is above -6, right? So if you draw a diagram, it says, first of all, x can be 6, right? Second, x cannot be 6. So considering both of the situations, x can be 6. And x must also be greater than -6, right? So the final solution is x must be greater than -6. Okay, because this interval has already included the point that x being 6. So we don't need to rewrite x is 6 in the final solution, right? Okay, any questions? No? Okay, let's see question 5. What is the possible range of M such that the system of inequalities has no solutions for X? Okay, so first of all, let's try to solve this system. So let's call this the star, okay? So inequality star is equivalent to, first of all, X smaller than or equal to 3M plus 9 over -8, right? Note that -8 is a negative number. When we divide both sides using a negative number, we need to change the direction of the inequality symbol here. So greater than becomes less than. Okay, second, divide both sides using a 6. 6 is positive, so we don't change the direction of the inequality symbol here. So second, x must also be greater than or equal to 2m plus 5 over 6, right? Okay, so let's call this K1 and let's call this K2. Next, we need to decide the relative positions of K1 and K2 in order that there's no solution for x, right? So which one should be larger? So suppose K1 is here. It says x must be smaller than or equal to K1, right? So can you tell me where should K2 be? K2 should be on the left of K1 or on the right of K1. Okay, left or right? You can write your answer in the chat dialogue. Okay, Dora. It should be on the right of K1, right? Okay. If you don't know the answer, you can just try. If K2 is here, let's say if K2 is on the left of K1, what will happen? According to the system, it says x must be greater than K2, right? If K2 is on the left of K1, so this is the overlapped area, right? In this case, there must be solutions for x, right? So it does not satisfy the conditions in the questions. So K2 must be to the right of K1, right? So K2 must be here. If K2 is here, x must be greater than or equal to K2. So that means x should be on the right of K2, right? In this case, there is no overlapped area. That means the original system has no solution for X, right? Okay, so you need to pay attention to the corner case. Can K1 be exactly K2? So that means, can these two numbers be the same? What will happen if the two numbers are the same? So if they are the same, this is K1, which is also K2, right? And according to the system of inequalities, it says X should be smaller than this number. And at the same time, it should be also greater than or equal to this number, right? So in this case, is there any solution for X? You think of this? Can K1 be exactly K2? No, because in this case, there must be a solution for X, which is X should be equal to K1 or K2, right? Okay, so according to the analysis, in this case, there is no solution. In the second case, there is a solution. So that means if K2 is strictly greater than K1, there is no solution. For X, right? And note that K2 greater than K1 is equivalent to 2m plus 5 over 6, strictly greater than 3m plus 9 over minus 8, right? Which is equivalent to, we can multiply both sides using the least common multiple of 6 and minus 8, right? Least common multiple of, okay, let's say least common multiple of 6 and minus 8, or should we say 6 and 8 is 24, right? So we can multiply both sides using 24. 24 times left-hand side. And because 24 is positive, so we don't change the inequality symbol here. Okay, this is equivalent to 24 cancels with 6, which is 4. 4 times 2m plus 5 greater than 24 cancels with minus 8 is minus 3 times 3m plus 9, right? Okay, and this is equivalent to, and then we only need to solve this inequality, right? 8m plus 20 greater than minus 8m minus 27, which is equivalent to, we can move the minus 9m to the left-hand side, which is 17m greater than, and then moves plus 20 to the other side, which is minus 47, right? And this is actually equivalent to m should be greater than minus 47 over 17, right? Okay, so the conclusion is if m is greater than minus 47 over 17, then there is no solution for X. Okay, did you get it? Please have a look at the whole process. Any questions you want to ask? Okay, no questions? Then, okay, then we'll move to the next one. Question 6, which is very similar to question 5, right? It asks you, what is a possible range of k such that this system of inequalities has no solutions for x? So first of all, let's try to solve the original inequality. Let's say this is star. So system star is equivalent to, first x should be greater than, okay, after dividing both sides using a 7, x should be greater than 5k plus 8 over 7, right? Note 7 is positive, so when you divide both sides using 7, we don't change the direction of the inequality symbol. So second, x should also be smaller than. Why smaller than? Because when you divide both sides using -4, -4 is negative, so we need to change the direction of the inequality symbol, right? So x should be less than 3k minus 5 over -4, right? Okay, so let's call this M1 because k has been already used. So this time let's use M1 and M2. And then we need to decide which one is larger. Okay, let's say if M1 is here, and according to the system, x should be greater than M1, right? So x should be to the left of M1. Now, can you tell me what is the relative position of M2? Should be on the left of M1 or should be on the right of M1? Left or right? Such that there's no solution for x. Left, right? Okay, so it must be to the left of M1. Okay, in this case, according to the system, x should be smaller than M2. So x should be to the left of M2 here, right? And as you can see in the diagram, in this case, there is no overlapped area. That means there is no solution for x. So according to the analysis, we can see that if M1 is greater than M2, there is no solution for x. Okay, so again, you need to consider the corner case. Can M1 be exactly M2? That means, can this case possible if M1 is also M2? Is it possible that in this circumstance, there is no solution for x? So can you give me an answer? Can M1 be M2 exactly? Yes or no? In order that such that x has no solution. Dora? Yes, because when M1 is M2, according to the system, x is greater than this number, and also x should be smaller than this number, right? For the same number, x cannot be both greater than or less than, right? So under this circumstance, there is also no solution for x. So we can put an equality symbol here. Okay, so the conclusion is if M1 is greater than or equal to M2, there is no solution for x. Okay, and all we need to do is to solve this inequality. M1 is greater than or equal to M2. This is equivalent to, okay, M1 is actually 5k plus 8 over 7. We need to substitute M1 using the exact expression. Greater than or equal to M2. What is M2? M2 is actually 3k minus 5 over -4, right? Okay, now we need to remove the denominators. Note that the least common multiple of 7 and 4 is 28, right? So we can time a 28 to both sides in order to remove the denominators. And 28 is positive, so we don't change direction of the inequality symbol here. Okay, this is equivalent to 28 cancels with 7, which gives us 4. 4 times 5k plus 8 greater than or equal to 28 cancels with 4, minus 4, which is minus 7 times 3k minus 5. Okay, this is equivalent to 20k plus 32 greater than or equal to minus 21k plus minus 7 times minus 5 is plus 35, right? Okay, then separate the k's with coefficients, which gives us 41k greater than or equal to 3. So this means k should be greater than or equal to 3 over 41 in order such that there's no solution for x, right? So now we can make the conclusion. If k is greater than or equal to 3 over 41, no solutions for x. Okay, please have a look at this. Any questions? No? Okay, let's see question 7. In the 2D Cartesian plane, shade the region which is a solution to the inequality x minus 3y greater than or equal to 9. So before we do this, let's go briefly go over how do we find the region that corresponds to an inequality. So suppose we have a 2D Cartesian plane, and we know that the equation of a line is y equals fx. Suppose this is the equation of this line, okay? So any region that is above this line, the region above this line can be expressed as y is greater than fx, right? And the region below this line can be expressed as y less than fx. Understand? Okay, this gives us a hint. How do we find the corresponding area given the equation of the boundary line? Okay, this is the method. Okay, so back to this question here. First of all, in order to find the region, we need to find the equation of this line first, right? Okay, so first of all, we need to separate x and y. Okay, so the original inequality is equivalent to, as we said, we need to separate x and y. So 3y less than or equal to x minus 9, right? And this is equivalent to y is smaller than or equal to 1/3 of x minus 3, right? Okay, so the corresponding line is y equals. You only need to change the inequality symbol to equality symbol. So the corresponding line is y equals 1/3 of x minus 3. This is our line, right? And next, we need to find this line in 2D Cartesian plane. Okay, so how do you find this line? A common method is to find its x-intercept and y-intercept and connect these 2 points to form a line, right? So when x is 0, y is -3, right? And when y is 0, x is, so when y is 0, that means 3, 1/3 of x minus 3 is 0. That means x is 9, right? Okay, so we know that when y is 0, x is actually 9. Okay, so there are 2 points on this line that we have already known. When x is 0, y is -3. So suppose -3 is here. And when y is 0, x is 9. Okay, suppose 9 is here. We know that this line must cross these 2 points, right? So by connecting these 2 points, we can easily find the line here. Okay, this is a boundary line. And note that it asks you to shade the region that is corresponds to the inequality, right? The inequality says y must be less than or equal to. Less than or equal to means the region must be under this line, right? So this is the region we are looking for. Okay, you understand? This is a region that corresponds to the inequality. Okay, any questions? Any questions? No? All right, let's see question 8. The question 8 is actually the reverse process, which gives you the line and asks you to find the exact expression of the inequality of the shaded area shown below. Okay, so first of all, we need to find the equation of this line, right? How do you find the equation of this line? We know that this line crosses 2 points. One point is 6, 4, the other point is 4 minus 2. So first of all, we can find the slope of the dot line. Okay, let's say the slope of, let's call it L1. Slope of L1 is delta y over delta x, right? Delta y is 4 minus 2 over delta x. Delta x is 6 minus 4, right? Which is 6 over 2, which gives us 3. Okay, next, we know the slope and we know one of the points. And then we can write the equation of this line using point slope form, right? Okay. Then the equation of line L1, we can use point slope form. Is, okay, according to the point slope form, Do you still remember how this form can be written? Y minus y0. Y0 is a given y coordinate, right? We can choose either point. So let's say we choose this point here. Y minus y0 equals slope 3 times x minus x0. X0 is given x coordinate, which is 6, right? So this is actually the equation of this line. So let's try to simplify this. Y equals 3x minus 18 plus 4, right? And this is equivalent to y equals 3x minus 14. Okay, so this is actually the equation of L1, which is a boundary line, right? And also we know that the area is actually below this line, right? Okay, let's say note the area, okay, the shaded area is below this line. Therefore, the expression of the shaded area is 1 below this line. That means y must be smaller than 3x minus 14, right? So can we put an equality symbol here? To decide if we can put an equality symbol here, the only thing you need to observe is this line a dot line? If a dot line, that means the area cannot be on this line. So that means y should be strictly smaller than the expression on the right-hand side. We cannot add an equality symbol here, okay? Did you get it? Any questions? Okay, so this is the expression of the shaded area. No questions? Okay, let's move on. Question 9. Okay, question 9. Graph the region of the points such as that satisfy both inequalities. Okay, this time we have two inequalities, right? We need to find the overlap area. Okay, so let's call this, sorry. First of all, we need to find the corresponding two lines, right? Okay, let's say the first inequality. We need to separate x and y's, right? First inequality is equivalent to y is greater than 2x minus 4, right? And let's say line L1 is y equals 2x minus 4. This is a boundary line of the first region, right? Okay, and we need to find the line on the Cartesian plane. So how do we find this line? Again, the easiest way is to find its x and y intercept, right? And we know when x is 0, y is minus 4, right? And also when y is 0, x, okay, when y is 0, that means 0 equals 2x minus 4. So x must be 2, right? So it line L1 crosses 2 points. One point is 0 minus 4, which is about here. The other point is 2, 0. Okay, 2, 0 is about here. So first line must be look like this. At this time we use dotted line because the inequality is a strictly greater than. So we use dot line. Okay, this is our first line. So usually we'll put a letter to denote which line this is. Let's put L1 here, okay? All right, the other inequalities. 2x plus 3y minus 6 less than 0, which is equivalent to, we need to separate x and y's. So 3y smaller than minus 2x plus 6. And which is also equivalent to y smaller than minus 2 over 3x plus 2, right? Okay, so let's say this is line 2. So the equation of line 2 is y equals minus 2 over 3x plus 2, right? This is a boundary line of the region 2. Again, we need to find this line onto the Cartesian plane by finding its x and y intercepts. So first of all, when x is 0, y is of course 2, right? Next one, y is 0. That means 0 equals minus 2 over 3x plus 2. We can easily solve that x should be 3, right? Okay, and now we know the second line, which passes 2 points. One point is 0, 2. 0, 2 is about here, okay? And the other point is 3, 0. 3, 0 is about here. Okay, so this must be the second line. Okay. Second line is L2. All right. Sorry, I forgot to mark the region corresponding to L1. So L1, it says y should be above L1, right? This is our first region. Above L1 is here. Okay, for the second region, the inequality says y should be smaller than. Smaller than means the region must be below this line, right? Below this line, we can mark it like this. So what is the overlapped area? By observation, the overlapped area must be here, right? This is the boundary of the area. And the overlapped area must be here. Can you see that? Okay, any questions? No? All right, let's see the next one then. Question 10. Okay, question 10 is very similar to question 9. There is an expression that this time we have 3 expressions, right? It asks you to graph the region of the points that satisfy all of the following inequalities. Okay, so let's consider them one by one. First of all, the first inequality is equivalent to, again, we need to separate x and y's. So 3y smaller than or equal to minus 4x plus 21. which is equivalent to y is smaller than or equal to minus 4 over 3x plus 7, right? And the corresponding line, let's say L1, is y equals okay, let's put it here then. Okay, the corresponding line L1 is y equals minus 4 over 3x plus 7, right? And we know that when x is 0, y is 7. And when y is 0, you can easily solve that x must be 21 over 4, right? And we can easily find this line on the 2D Cartesian plane. Okay, it passes 2 points. One point is 0, 7. Let's say 0, 7 is here. And next point is 21 over 4, 0. So 21 over 4 is here. All right, and the corresponding region of the corresponding line must be passes through this point. So this line is here. This is our first line, right? And we can call it L1. And corresponding region, it says y should be smaller than. So smaller than means the region must be under this line, right? So this is the region. Okay, must be under this line. Okay, next, the second inequality, which is 2x minus y greater than or equal to minus 2, which is equivalent to y smaller than or equal to 2x plus 2. And corresponding line L2 is y equals 2x plus 2, right? And in order to find this line, we need to find its intercept. So when x is 0, y is 2, right? And we also know that when y is 0, x is minus 1, right? So that means it passes 2 points. The first point is 0, 2. 0, 2 is around here. And next is minus 1, 0. So let's say minus 1 is here. Okay, so the second line must pass these 2 points. This is a line, this is second line, which is L2. And corresponding region, it says y should be smaller than 2x plus 2. That means it corresponds to a region that is below this line, right? Below this line means here. Okay, and remember that there is another inequality, which is y should be greater than or equal to minus 3. Okay, the corresponding line is L3. L3 is y equals minus 3. So this line is much simpler, right? Y equals minus 3 is actually a horizontal line that is parallel to x-axis. Okay, first of all, let's find -3. So suppose this is -3, and then the third line must be look like this. Okay, this is our L3. And according to the inequality, it says y must be above or equal to -3. So that means it corresponds to a region that is above this line, right? Okay, so by considering all of the three regions, the overlapped region is where? Can you find it? The overlapped region. First, it must be under the blue line, right? So that means this is a boundary under the blue line. Second, it must be also under the red line, which is L2, right? So there is another boundary line here. Third, it also must be greater than -3. That means it must be above L3. So this is another boundary, right? So the overlapped area must be shaded like this. The yellow shaded area here is our overlapped area, which corresponds to the three inequalities. Can you see that? Okay, and this solves this question. Do you have any questions? No? Okay, let's see the last question. Okay, last question gives us a system of constraints. And it asks you to find the maximum value of 3x plus 2y, such that the following three inequalities are satisfied. Note that the three inequalities here is actually the same with the ones we have in the previous question, right? Okay, this will save us a little time to find the overlapped region. Okay, and there is also a hint which will help you solve this question. In the hint, it says, suppose we must minimize or maximize a linear expression. Okay, this is called a linear expression, right here, in one or two variables, such that the variables satisfy a set of linear inequalities, and this is a set of linear inequalities. Suppose further that the set of all points that satisfies the inequalities in a bounded region. Bounded region means the shaded region can be exactly on that bounded the boundary line. Okay, so that means we have an equality symbol in these three inequalities instead of strictly greater than or strictly less than. Okay, instead of extending indefinitely in some direction. And suppose further that the inequalities are non-strict, okay, non-strict, so that the boundary point satisfies them. Then the point inside the bounded region that optimizes the desired expression must be a corner or vertex of the region. Okay, so what does this mean? This means in order to find the maximum value, 3x plus 2y, first of all, we need to find the constraint area according to the given system of inequalities, right? Specifically in this question, the shaded area or the shaded constraints is yellow region here, okay? And then the hint tells us that the optimized value can only be achieved in the corner case in the corner or in the vertex. That means 1, 2, 3, 3 vertex, right? Okay, so let's borrow this diagram we have already created to the last question. Okay, let's copy this to the last question. Okay, so the first step is to find the shaded area, which we have already done. The yellow shaded area is the overlapped area, okay? And next, we need to find all the vertices. In this specific problem, this is P1 and P2. And there's another vertex, P3, right? These are all the 3 vertices in the bounded region. So next, we need to find the coordinates of these 3 points, right? So how do we find P1? P1 is actually the intersection of L1 and L2, right? Which is actually, okay, we need to find the equation for L1, right? The equation of L1 is y equals minus 4 over 3x plus 7. And the equation of L2 is y equals 2x plus 2, right? And we need to solve this intersection by combining these 2 equations. This will give us minus 4 over 3x plus 7 equals 2x plus 2, which means minus 4x plus 21 equals 6x plus 6, which means 10x equals 15, right? So x equals 1.5. And then we put x equals 1.5 back into either equation 1 or equation 2. And then we can get y equals 5, right? So that means the coordinates of P1 is 1.55. Next, we need to find the coordinates of P2 by combining the equation of L2 and L3, which means y equals 2x plus 2. L3 is actually y equals minus 3, right? And this can be easily solved that the coordinates is x equals minus 2.5, y is minus 3. Okay, so the coordinate of P2 is minus 2.5 minus 3. Okay, and then we need to find the coordinates of P3 by combining L1 and L3, which is y equals minus 4 over 3x plus 7, and y is minus 3, which can be easily solved that x is actually 7.5, y is minus 3, right? Okay, so the coordinates of P3 is 7.5 and minus 3. So now we have the coordinates of P1 to P3, right? Next, we need to calculate the target function at each vertex. Okay, we need to use a table here. The first column is our vertex, which is P1, P2, and P3. Next column is our target. Our target is to maximize this expression, 3x plus 2y, right? So at point 1, at vertex P1, the target function, the value of the target function is 3 times x, x is 1.5, plus 2 times y, y is 5, which is 14.5, right? And at vertex P2, the value of the target function is 3 times minus 2.5 plus 2 times minus 3. This will give us minus 13.5, right? And at vertex P3, the value of the target function is 3 times x. X now is 7.5 plus 2 times y. Y is minus 3 now. And this will give us 22.5 minus 6, which is 16.5, right? Remember that our target is to find the maximum value of this expression. So can you tell me which one is maximum? Of course, this one is the maximum value, right? So what does this mean? This means now you can make the conclusion. When x is 7.5 and when x is 7.5, y is minus 3, 3x plus 2y has a maximum of 16.5, okay? And this is the whole process, how we can find the optimized value. So pay attention here. The question here can also ask you to find the minimum value, okay? Pay attention whether it's a maximum value or a minimum value. Okay, any questions? Okay, have a look at this. Do you have any questions? Okay, so in our next assignment, I'll give you similar questions to solve, okay? I hope you really learn something in this assignment. And please do remember to correct your mistakes, okay? Okay, I'll let you know once the new assignment is available in Google Classroom. And if you don't have any questions, you're free to leave. Okay, have a nice weekend. Bye.